So I'm going to show you the 4 steps by using numerical example. So, okay, so this is the first example. So when I first look at the example, I will look at my A, I will look at my B, and I look at my C. So from here, I know that later on I need to shift the graph down. Okay, so that means, right, I should be drawing this. So usually I will draw the one without shifting first, and then I will shift the graph down. Okay, so in this case, right, you can explore so with the idea of the amplitude, so this will be the highest, okay, this will be the lowest. Okay, the amplitude is actually the second step. So the first step should be you explore the period. So the period is 360. So remember, divide into 4 sections. So first step, get the period, and I divide the period into 4 sections. Second step, the amplitude is 3, so the highest is 3 and minus 3. So, and where are the special values? So the special values are here. This is a sine graph. Okay, so actually this is my dotted line because this is not going to be my final graph. So this graph, the dotted one, right, is actually y equal to 3 sine x. I have yet to shift down. So the effect of shifting down must be very obvious. So you literally shift down this point. So you will come to a minus 1. So you shift down this point, you will come to a 2. So every point must be shifted down. So every point must be shifted down. And then when you join the shifted graph, that will be the final graph. So this one will be the final graph. So from the dotted line, you should feel the vertical effect down. Okay, so it's always all right if you draw a dotted line first. So the next one is a cosine graph. Okay, there is a shifting up. So from here, that will be an amplitude of 3, and the period is 360. So again, I'm going to do the same thing. I'm going to divide the period by 4. So that's the first step. And the amplitude will tell me that is 3 or minus 3. Okay, please do some measurement. So at least maybe you calculate like this one can be 1.5 centimeter on your sketch. So then where are the special points? Here, 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 here. So the special values will guide you with a dotted line like this. So this one is like just 3 cosine x. You have not shifted up yet. So let's try shifting up. So if I shift this point up, it will go to a 5. So this will go to a 2. This will go to a minus 1. So you should feel a vertical effect. So this is the final graph. Is it okay not to draw the dotted line? I would think it's okay, but some people end up their graph is really ugly and there's no shifting effect. So I will think that it's actually better to draw the dotted graph before you do any shifting up and down. Okay, so let's carry on. So in the next one, right, we got shifting. And from here, I can tell the amplitude is 2 because A is 2. And then, right, B is 2. So the period will be 360 divided by 2. So you also got to mentally divide by 4. So it'll be something like this. So each period you divide by 4. And the highest is 2 and minus 2. So like I said, I'm just going to draw for one period first. So let's have some guiding points to draw for the cosine graph. So this is my one period. Do I need to draw some more? I'm supposed to draw until 360. So I need to draw some more. So I have another period to draw. You still divide. You still divide the numbers. Okay, you still divide the numbers. And then you still use the guiding point. You still use the guiding points to help you to draw another cycle, another period. So all these are the ones without shifting. So once you are comfortable with this, you add the shifting. So literally every point will be shifted up. So do not draw freehand. So from here, you really feel the graph being shifted up. So that is my final graph. Okay, then what about tangent? Okay, so tangent doesn't really have amplitude. So, but this part will be reflected in one of the special points. So the period here is 180. So you divide the period into 4 sections. So usually people don't divide into 4 sections. So if you divide into 4 sections, so if you still remember what I mentioned just now, the dotted line is half the period. So in this case, right, the period is 180. The asymptote should be half the period. So it will be at the 90 degree. So where is the special point? So we got 3 special points just now. So this will be the special point. And then if you try the 45, right, you can try punching 45. 2 times tangent 45, it will actually correspond to a 2. So this is like a special value to guide you. So then you can try like 135. It will actually give you a minus 2. So there's another special values to guide you. So some people, they don't have the extra points to guide them. So their tangent graph looks a bit weird. Okay, so that will be the 4 basic graph, as in like how you do the 4 steps. Okay, so if we extend it a little bit more, tangent 2x. So tangent 2x starts to change the period already. So the period changes. the period becomes 90 degrees. So the period becomes 90 degrees. Okay, I still divide my period into 4 sections. So I'm going to still divide into 4 sections. And half the period will still be my dotted line. And I still got my special values here. If you punch this part, 22.5, 2 times 22.5, you will get a 1. Or you change to 67.5 here, you will get a -1. So again, right, this is going to gut you. This will be the special values that's going to gut you. And I need to draw for until 180. That means I need to do another period. So I repeat, divide another period into 4. Half the period is going to be the dotted line. I think I got this number wrong. This shouldn't be 270. Okay, this is 135. So if you use this value, again, there's a guiding point to guide you. So here, there's another guiding point. So that's how tangent 2x looks like.